Okay, we're back. Actually, I just hit stop and then hit start again. Welcome back. We're going to look at part E, which is the asking about this observation equation, which is something we didn't get to in the TD, but it's quite important. The observation equation is the pair to the transition equation. Okay, what is the transition equation, you ask? Thank you so much for asking. This is called the transition equation. Why? Because it transitions us from t to t plus 1. And then we have an observation equation. Why is it called an observation equation? Because it transforms the state variables. Okay, so recall that xt equals yt minus 1, yt minus 2. So it takes, and these are the states, and then yt is going to be the jumpers. It's going to be equal to ct, it, and gt, and these are the jumpers. Why are these jumpers? Because once we know xt, once we have xt minus 1, xt minus 2, then we can immediately compute ct, it, gt. How do we do this? Well, that's right. Remember our initial equations. We don't have them written down here, but they're not so hard. We need to recall that y is equal to c plus I plus g, and there's time subscripts on all these, t. That's ct equals gamma plus a yt, it equals b yt minus 1. This is minus 1, of course. I apologize. It's not actually an of course. I mean, who knows? Why is this yt minus 1? Actually, you should be able to tell me why this is yt minus 1, right? Because people plan for the future. They don't know what is yt yet. They're making a plan for the next period. And then gt is just a constant of g bar. Okay. Yeah, and I mean, in principle, yeah, I mean, you could even include yt in this y equation. I mean, this can be jumpers, and then we can put in parentheses, maybe plus states. That's up to you. Because you can also compute the states from the states, right? The transition equation does exactly that. We could also put yt here, and then we would just have to repeat the first row of the A matrix inside of the Z matrix. Okay, but definitely the jumpers go in here, but also maybe the yt. Why would you do this? It's convenient if you're in Python. You don't want to have to look at two objects. You just do one multiplication, then yt has everybody. You don't have to think about, oh, did I leave my state variables here? Are they here? So it can be nice to put them together. That's an aside. Okay, so what does it want us to do? It wants us to find this Z and this C matrix. Okay, let's do it. The way to do it first is to write down our objects and think about shapes. When you think about these matrix equations, you always start by reasoning about the shapes. So here we have a 3 by 1. We have a 3 by 1, and that's going to be equal to something. Okay, we don't know what shape it is yet. It's something. But we know xt. xt is a 2 by 1. So already we see that zt, right away, you should see that zt is not square. Why isn't it square? Because it's going to transform a 2 by 1 vector, xt, into a 3 by 1 vector, yt. 2 by 1. But we know it's going to be something by 2 because it needs to match. And then we know the other number is 3 because we're going from 2 thing space to 3 thing space. So it's going to be 3 by 2. And then likewise, we now know that our C matrix, which is the constants, is going to be a 3 by 1 because that will match with yt itself. 3 by 1. Great. So let's start with recalling that once again we are dealing with each row of the system is an equation. Okay, so the CT equation will go in the first rows of Z and C, and the IT will go in the middle, and then GT will go in the bottom. So right away, GT should be very clear. We have a 0 and a 0, because we look at the GT equation, we don't need anything. We don't need any YT minus 1, we don't need any YT minus 2. And in the C, we need some G bar. There you go, done. That's the row for G. We take 0 of YT minus 1, we take 0 of YT minus 2, and then we add G bar. Okay, now IT, this shouldn't be so difficult. We just need to factor. We see that YT minus 1, we need B of YT minus 1, and we need minus B of YT minus 2. Okay, remember that you can only add and multiply, so we have to put the minus sign with the B here so that it works out in the matrix multiplication. For constants, there's no constants for IT, so we just bring along a 0. And lastly, for CT, we need A of YT minus 1, and we need 0 of YT minus 2. I'm looking at this equation now. We need A of YT minus 1 and 0 of YT minus 2. And then for C, we need gamma. And there you go. So you can see that when we do the matrix multiplication, bang, we go 1, 2, and we get A YT minus 1 plus gamma, we get back the C equation. We do B times YT minus 1 minus B times YT minus 2 and add them. We get B times YT minus 1 minus YT minus 2. We add 0, we get the IT equation. And GT, we just add G bar. Now, if we wanted, okay, so now you're done. This is the answer to E. But if you wanted to carry along YT here, then now we have a 4 by 1 vector for our YT. We get a 4 by 1 for our Z. This remains 2 by 1. We still only have 2 states. And this is 4 by 1. Okay, so what is the last column of Z and C? Well, first we need to remember the reduced form. We'll have to plug these back into YT, and I hope that we recall that we'll get something like YT is equal to gamma plus G bar plus A plus B YT minus 1 minus B YT minus 2. And so now we see. We need, in the Z matrix, we're going to add A plus B, because we need A plus B of YT minus 1. We need minus B of YT minus 2. And for the constant, we need gamma plus G bar. So there you go, you're done. If you wanted to bring along this, of course, you're doing the computation twice because you're computing Y here. But then if you like, you have all the information you need to compute it again here. So I can show you, you just stack them up and just remember to think in rows. Think in rows are equations, and columns are states. Okay, and every spot is a parameter. And this notion becomes very important when we study RBC. But matrices are your friends. They're not complicated. Rows are equations, columns are states, and cells are parameters. And you can summarize a lot of information in a very easy way. We just write down this. You don't need to write down all of this or all of this. Just 2 little equations, and it's very powerful. Great. So let's move on to the next couple questions. I'll see you there.